Hello, we will practice using properties of polynomials to find characteristics of the of a polynomial. So, for instance, let's say that we had this question: how many possible real zeros are there in this polynomial? And we have x to the 6 minus 3x to the 5 minus 2x to the 4th plus 8x cubed minus x squared minus x plus 3. So, as you might recall, I said that the number of sign changes tells you the number of possible positive real zeros. But here we don't have the word positive. So how can we find all the real zeros? Well, you know that if you add the positive real zeros plus the negative real zeros, you will get all possible real zeros, right? But now you might ask yourself, well, how do I find the negative real zeros? Well, you can find that by plugging in negative x for all your x's. So if this is f of x, you find f of negative x, and then using the same thing we learned before, counting the sign changes, you will be able to find also the number of negative real zeros, the possible number of negative real zeros. So first, let's do what we know how to do and find the number of possible, just remember that it's possible, positive real zeros. So here we have from plus to minus, so that's 1. From negative to negative, doesn't change anything. From negative to positive, this is 2. From positive to negative, that's 3. From negative to negative, that's nothing. And from negative to positive, that's 4 sign changes we counted. So the number of possible positive real zeros is 4. And now let's do what I told you to find the possible negative real zeros. Okay, so here we have f of x is equal to the polynomial we had before. Now let's find f of negative x. So we will plug in negative x wherever we see an x, like so. Okay. So now, let's simplify this to be able to find the number of sign changes. So negative x to the 6, you know that this is basically negative 1 times x to the 6, which can be turned into negative 1 to the 6 times x to the 6, and negative 1 to the 6 is just 1 x to the 6. So actually negative x to the 6 is actually x to the 6. So this is something to know, that if the power or the exponent, however you want to call it, is even, then f of x is equal to f of negative x for that term. So let me, instead of using f, let me use g, so you don't get confused. I'm not talking about this f of x right here, I'm just talking for that given term. So knowing that, we can go through this pretty quickly. And so we have f of negative x is equal to x to the 6th, then negative x to the 5th, that is negative x using the same way of simplifying everything as we did for negative x to the 6. You can do it by yourself and you will see that you are left with negative x to the 5th. And so negative x to the 5th times negative to the 5, times negative 3 is positive 3x to the 5. Here, remember, negative x to the 4th is just x to the 4th, and so negative 2x to the 4th. Here, this will be negative x to the 3rd, so minus 8x cubed, then minus x squared plus x plus 3. Now let's see how many sign changes do we have. So we go from positive to positive, negative, 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 positive, positive. So here we find one transition, two transitions, two sign changes. So here we found that the number of positive real zeros positive real zeros was 4. The number of negative positive real zeros we just found to be 2 transitions right there, plus 2, and that's equal to our total possible real zeros, which is 6. And so just by knowing that the way to find the possible negative real zeros is by finding f of negative x and doing this same thing as we did before, finding the sign changes, then combining those two concepts, we are able to find the total possible real zeros of a polynomial.